Ever struggled with cryptic parameter names like Q when your AI tools should be crystal clear? You'll see exactly how to transform a basic search tool into a more intuitive version by renaming Q to search query, all while keeping the original logic intact. This pattern lets you adapt tools for better AI understanding without rewriting a single line of core functionality. From FastMCP, import FastMCP. From FastMCP Tools, import Tool. From FastMCP Tools Tool Transform, import ArgTransform. MCP equals FastMCP. At MCP, Tool. Def search Q, SDR. Searches for items in the database. Return database, search Q. New tool equals tool from tool. Search. Transform args equals Q. ArgTransform name equals search query. This demonstrates the tool transformation pattern, a declarative approach for adapting existing functions into specialized interfaces without modifying their core implementation. The technique creates wrapper tools that modify argument names, descriptions, or behavior while preserving the original logic, enabling clean separation between interface design and business logic. What makes this distinctive is its ability to treat tool interfaces as configurable layers rather than fixed contracts. The pattern works by composing transformations through a fluent interface, where each transformation defines how arguments should be renamed, documented, or hidden from clients. Under the hood, it maintains a chain of responsibility. The transformed tool handles schema presentation and input validation, then delegates execution to the original function with properly mapped arguments. This design keeps transformation logic decoupled from business logic, while ensuring type safety and discoverability. This approach solves the common problem of interface mismatch between generic backend functions and domain-specific client needs. It eliminates boilerplate wrapper code while making tools more intuitive for AI clients or specialized use cases. The trade-off is a slight runtime overhead for argument mapping, but the benefit, maintaining a single source of truth for core logic while supporting multiple interfaces, far outweighs the cost in most scenarios. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for defining AI callable tools. It serves as the bridge between your Python functions and AI models, enabling structured function exposure with automatic schema generation from type hints and docstrings. From FastMCP Tools, import Tool. This imports the tool class FastMCP's abstraction for wrapping Python functions as AI callable tools. It provides the factory method FromTool, used later to transform and register the search function with modified argument names. From FastMCP Tools Tool Transform, import ArgTransform. This imports ArgTransform, a utility for renaming or modifying tool arguments before execution. It enables mapping between AI-friendly parameter names and internal Python function parameters. MCP equals FastMCP. Instantiates the FastMCP core controller. This central object manages all AI callable tools, handles registration, and coordinates execution between Python functions and AI models. At MCP, Tool. Def search Q, SDR. Searches for items in the database. The at MCP tool decorator registers this function as an AI callable tool in FastMCP. The type hint and docstring automatically generate the tool schema, defining the input contract and behavior for AI models. This is the standard pattern for exposing Python functions to AI orchestration. Return database, search Q. This executes the actual database search using the provided query string. The function acts as a thin wrapper, delegating the core search logic to the database layer while maintaining a clean interface for AI tool integration. New tool equals tool from tool. This creates a new tool instance by cloning the existing search function. The from tool factory method preserves the original function's logic while allowing argument transformation, enabling schema customization without rewriting the implementation. Search. This passes the original search function as the source for tool creation. It preserves the function's logic, docstring, and type hints while allowing FastMCP to transform its argument names and behavior through the ArgTransform configuration. Transform args equals. Transform args remaps function parameters to AI-friendly names. This decouples your internal Python API from the external tool schema, letting you rename arguments without breaking AI integrations. Q. ArgTransform name equals search query. This renames the parameter Q to search query in the tool's external schema, decoupling the internal function signature from the AI-facing API. Critical for versioning, you can change internal parameter names without breaking existing AI integrations. This closing brace terminates the transform args dictionary definition, finalizing the argument transformation mapping for the tool. It ensures the ArgTransform for the Q parameter is properly registered before creating the new tool instance. This closing parenthesis terminates the tool from tool call, finalizing the transformation of the original search function into a new tool instance with modified argument naming. The transform args parameter remaps the original Q parameter to search query in the tools schema, making it more descriptive for AI model interactions. Tool transformation pattern. The ArgTransform system in FastMCP 2 lets you reshape tool interfaces without modifying the underlying implementation, creating a separation between internal logic and external presentation. Hidden arguments must always have default values, since the LLM can't provide them at runtime. This pattern enables backward-compatible API evolution while maintaining clean internal code.
The argument that vanishes from the schema still answers every call.